you, Doc.
Hello.
Doc, I can hear you loud and clear.
Okay, fine. Now we actually just want to start. So I'd like to take this opportunity to introduce the Richard. So members feel welcome. Actually, this presentation was there a couple of days ago, but since many people are not able to attend, and that's why we migrated from the platform we were using, Zoom, to Telegram, which we thought could accommodate more people than Zoom. So it's a repeat presentation. Richard, briefly I can say, is a software developer with over 20 years experience, and he has hands-on skills, hands-on experience with the artificial intelligence tools, such as LLAMA that he's going to present this evening. So members feel welcome. He will present, then thereafter we shall have a question answer session, and I'll be coordinating that. So Richard, you're welcome.
Thank you very much, Dr. Wakoli. And thank you, members, for taking time to come and attend this particular meeting. It's a great pleasure that you've taken your time. As Dr. Wakoli has mentioned, this is a makeup class based on what we had last time. And most of the members, or some of the members, could not be able to gain access for one reason or another. Of course, it was basically an issue of the platform you're using, which could not be able to allow us to accommodate more than 100 members at a time. That's why we have moved towards this new platform. So feel welcome, and we are going to be using this particular channel for this particular lecture and the future lecture series that we are going to have. So as mentioned, we're just going to have a makeup of what we covered last time, which is Introduction to LLAMA 3.1 and its relevance to education. So Dr. has already introduced me. So my name is Richard Akelo. I'm a software engineer by profession, and I'm also a trainer. I have an interest in AI and other systems like financial systems, school management systems, HR and payroll, and such like stuff. So let's go straight into what the discussion today is all about. So, sorry, I don't know why my presentation is not okay. Didn't know why my presentation was not moving. So just a second, I don't know why the presentation is a bit jittery. So introduction to LLAMA 3.1. So what we're going to do is we'll try and understand what this discussion is all about. I'm having trouble with the presentation. Just a minute. Let me just try and see how to. Let me just play the slideshow again. Oh, perfect. So this discussion will be about LLAMA 3.1 and its impact in education. So LLAMA 3.1 is a state-of-the-art open source large language model deployed by Meta, developed rather by Meta, and it's designed for versatility in various applications, especially what we refer to as natural language processing. Now, as we are aiming to discuss what these three components are, we will need to look at LLAMA from a perspective of artificial intelligence, machine learning, what we call deep learning, and then, of course, now the large language model, because they take precedence in that particular order. Now, LLAMA 3.1 aims at improving the interaction between human and machine, making technology more accessible and efficient. As you have seen in the past, nowadays using things like chatbots, something like ChatGPT or Microsoft Copilot or Google Gemini or Cloudy from or even Grok. So all these things have made it very, very easy for us to be able to talk to machines. They're able to do certain things for us, like answering questions, classifying items, generating points, and all these kinds of stuff. So as part of making technology more accessible, LLAMA 3.1, that is Meta. Meta is the company that owns Facebook, WhatsApp, and Instagram, came up with this particular model, and it's open source, which means that it will enable us to be able to integrate into our applications. The only thing we probably need to do is train the models, give it some data to work with, then integrate it into our ecosystem for efficiency's sake. Now, what is the relevance of LLAMA in education? Now, LLAMA 3.1 has a potential to transform learning experiences by personalizing education. Personalizing education, we're going to discuss in detail, from ECD all the way to how environmental sustainability will work out. So that's going to be a major factor in as far as this particular discussion is concerned. Besides personalizing education, it also enhances engagements, which means that we can be able to engage with machines and have meaningful conversation, including training or things like that. Then, and of course, also supporting diverse learning needs. Remember, we have different learning needs. We have people who have disabilities. We have people who don't have access to textbooks. We have places where we don't have access to things like laboratories. We have places that are infested with security issues and so on and so on. So LLAMA 3.1 aims at supporting these diverse learning needs as they come into play. And those are some of the things that we are going to look at as far as this discussion is concerned. So LLAMA 3.1, what is it? Now, just as I mentioned, we need to discuss three things before we come to LLAMA 3.1. So first of all,
Richard, your slides don't seem to be moving. I don't know.
My slides don't seem to be moving.
They don't seem to be
okay,
moving.
I don't know if it's an issue of because personally on. Let me just check. I think it's because I was putting it in presentation mode. Well, I think I'll just have it, let me just have it this way, so that way it should be able to move. Let me just try to move up and down. That's okay now? Is it now moving?
I think it's okay. You can now navigate, try navigating up.
Okay, fine. So I was talking about LLAMA 3.1, and LLAMA 3.1 is a large language model. So before we got into large language model, I wanted to discuss a few things here and there, and one of them is artificial intelligence. So what is artificial intelligence? So AI is where we train computers to be able to talk, to operate or do things that the human beings are able to do. For example, reasoning, classifying things, even motion. So when we train machines to do such things, it means that we are not programming the machine exclusively to be able to do this work. So we're just giving it some sort of data. Then based on this data, it is able to make inference or decisions based on exactly what it requires to do. So that's artificial intelligence, us giving computers the capability of making decisions based on data and certain rules that they can be able to work with. There's somebody typing very, very hard at the background. Maybe you can mute your mic as you're typing. All right, so that's AI. Then besides AI, we have machine learning. And machine learning is a branch of AI which is now concerned with the different models that we can be able to use to be able to train these machines. For example, how to classify things. And when it comes to machine learning, we have different models. We have what we call supervised learning, where in supervised learning, we are saying we label things like, I'll say, this is a chair, this is a table, this is a microwave, and so on and so forth. And I have different labels for different pictures of different items, then the AI, based on the labels, it is able to know that tables are supposed to look like this, chairs are supposed to look at this, and so forth and so forth. That is supervised learning. Then we have unsupervised learning, and in unsupervised learning, we don't label the items, but the engine tries to classify these things together. There could be things like categories of suppliers, for example, or maybe age brackets, or really depending on the sets of data that you're working with, maybe say classification of email as spam or things like that. That is unsupervised learning. So there is no labeling, but now the AI should be able to use the data that has been provided and try to group things that are similar together. Then, of course, now we have reinforced learning, which is a hybrid between the two. Something like a self-driving car, we can allow it to be able to read road signs. We tell it how road signs look like, but at the same time, we're able to allow it to drive based on things like speed limits or things like that, or maybe detect objects like people who are crossing the road and stuff like that. So that is what is referred to as reinforced learning. Now, when you're talking about machine learning, these are basically what machine learning entails. Then we have deep learning, and in deep learning is now a branch of machine learning where now it involves using what we call neural networks. There are different types of networks that you can use. We have neural networks, which is the most popular one. And in neural networks, it means that we have various nodes where we take data, passed on one node, and these nodes are passed into other nodes, and they are processed in parallel. So this is actually like for a self-driving car. If I wanted to be able to detect somebody is moving, I have a camera, I have a LiDAR, I have infrared. At the same time, I could have things like microphones and vibration sensors, and all these things are giving this computer or the graphical processing unit all the data that is processing to be able to know that somebody is crossing, somebody is talking on the phone, a dog is barking, another car is driving besides it, and all those kinds of stuff. So again, that's basically what deep learning is concerned with. So we'll have this neural network similarly modeled similar to the human brain, where now we have data emanating into various cells, and all these things are able to process the data and be able to conclude that this data is either it's called, for example, if you wanted to know something is hot, you'll have to touch it. Then the touch has to send the signal to your brain. Then your brain sends the signal to your nervous system and all those kinds of things. Then you're able to feel that actually this thing is hot. So literally, that's how what we call deep learning works. Then inside deep learning, now we have what we call the large language model. So within the large language model, now we are able to process what you call textual data. So you can process textual data, take this textual data, pass it to the deep learning algorithm, which is a form of machine learning, which is actually artificial intelligence. So that is the relationship between those four components. So when you're talking about an LLM, it's basically designed to understand and generate human-like text. So it will be based on text, but of course it connects to the other components of the AI to enable it to work effectively. Now, LLAMA 3.1 is part of the LLAMA series by Meta, which features enhanced architecture for superior performance. We have had different versions of LLAMA. We started with version 1, we went to version 2, then we went to version 3. Now we are at version 3.1. Of course, there's version 3.2, which is already out, but we are going to focus this discussion on LLAMA 3.1. So it is superior to 3.0 in the sense that it has enhanced architecture, which makes it a very, very superior in terms of performance. Now, it's also capable of performing various tasks, which will include answering questions. And this is something that most of us use it on an everyday, as part of everyday activity. We simply have a question, we want to do a search, we are able to tell exactly what this is all about. So besides answering questions, we have summarization. Summarization is where I can have a very large piece of text, then I want to summarize it. Maybe I have 30 pages document and I want to summarize it in, say, 4 pages. It is able to take that data, comprehend it, and try to summarize it in a way that has been recommended without really losing the meaning of the context. Then there's the translation part, which means that some of these models are able to do translation in different languages. So I could want to speak in French, and somebody does not understand French, they only understand English. So it could be able to take that particular input, do the processing, then it is able to translate it back to the language that somebody else understands. And we have tried this in various aspects, and we're going to demonstrate how this works out in a few. Then there's also the context of context generation or generative AI, whereby now we ask AI to generate things for us. So, for example, I could ask AI to generate for me a topic as far as web development is concerned. Suggest for me topics that would be relevant when it comes to web development, and it will dutifully do that very, very accurately. So those are some of the capabilities that large language models like LLAMA are capable of doing. So what are the key characteristics? One, they're scalable, which means that they're efficient and adaptable to a variety of educational contexts. Okay, so that is a brief introduction of what LLAMA is. Now let's look at the different models of LLAMA 3.1. Now LLAMA 3.1 comes in 3 models, and these models are named or are labeled based on the parameters within which they have been trained on. So we have LLAMA 3.1, 8 billion, which has 8 billion parameters. It is the fastest model as far as LLAMA is concerned because it is lightweight. It is not as big. I think the data size is about 4.7 gigabytes at most. So it is the fastest, but the least accurate of all of them. Of course, it's moderately accurate, but compared to the other 2 models, it is the least accurate. Speed, remember in speed, in terms of computing, we usually sacrifice one thing. We have what we call time complexity and space complexity. Time complexity is how long it takes to perform a certain task. And space complexity is how much memory and processing power is required to perform that particular task. So you have to sacrifice one of them. Are you going towards the space complexity part or the time complexity part? You decide which one you want to go to. Now, LLAMA 3.1 takes care of the time complexity, which means it's very, very fast. Okay. So the time complexity has been dealt with over here. Now, some of the applications that we can be able to use with LLAMA 3.1 are things like chatbots or even educational tools, like maybe say generative AI, where I want to generate topics on a certain subject, or I want to just to ask it questions on certain things, maybe events that happened in history or things like that. It is very, very good with such kind of things. So generative AI and question answering and even summarization, it will be able to do it pretty fast. Now, in terms of resource requirement, it requires moderate computational power, because it is relatively fast in terms of its response. Then you have LLAMA 3.1 with 70 billion parameters. This one is very highly accurate. It is used in complex scenarios which require nuanced understanding and advanced research analysis. An example of where you'd use this is in what we call virtual assistants, something like Siri or Alexa or Google, where I can be able to control or to ask it questions, and it's able to take my text, convert it back to speech, and try to understand the subject matter that I'm discussing about, and it tries to be as accurate as possible in terms of that information. So that is LLAMA 3.1, and those are some of the use cases as to where you can be able to use it. Now, it is highly accurate, but it is not also very, very large compared to the other model. Well, it requires a reasonably higher computational power and potential latency. There's some sort of potential latency in its response. Latency is the amount of time it takes for you to be able to generate a prompt. It processes the prompt and gives back feedback. That time lapse is what is referred to as latency. So when it comes to the 70 billion parameter, there's quite a bit of this potential for latency as far as response is concerned. Then the third version of LLAMA 3.1 is the 450 billion. Now, this is the most accurate version of LLAMA that is there, and it's the one that compares to things like Google Gemini or Microsoft Copilot or Cloud 2 or even XAI Grok. XAI is the company by Elon Musk. They have their own AI model called Grok. So this is the one that compares to these other models. As we are saying, the LLAMA 3.170 billion compares to ChatGPT 3.5, but the 450 billion compares to ChatGPT 4.0 or Omni, as they call it. So they are usually compared in that particular aspect. It is exceptionally accurate, but it also requires high computational power. And this particular case, we'll be talking about clusters of servers. In the 70 billion, maybe we could be talking about just a server. In this 450 billion, we could be talking about clusters of servers, and they're not just one. There could be 10, there could be 100, there could be 1,000. It all depends on really what this particular AI is actually being used for. Now, where is its application? It's used in cutting-edge application like research, things like DNA sequencing, for example. That is not a very easy thing. Things like Google Maps, for example, calculating the shortest distance between two places. Now, that seems like a very trivial solution, but for those people who know geography, the shortest distance between two places is not the direct distance between them. There could be the road distance between the two places, and that has several parameters that have to be put in place and be calculated in order to be able to get this kind of information. So those are the three models of LLAMA 3.1 that are actually available in the market at the moment. Of course, you can use any of them. It will depend on how much processing power you have at your disposal in order to be able to run any of them. So let's look at some of the key features of LLAMA 3.1. And one of them is improved accuracy. Compared to LLAMA 3.0, that is, of course, we'll be comparing LLAMA 3.1 with LLAMA 3.0 or earlier versions of LLAMA. And when you're talking about improved accuracy, it is more precise in terms of text generation and comprehension, leading to better educational outcomes. Like, for example, in terms of context, this thing is context aware, which is another advantage of it. If I'm discussing physics, it knows that I'm talking about physics. If I move to geography, it knows I'm talking about geography. If I'm in summarization, it knows I'm doing summarization. If I'm in translation, it knows that I'm doing translation, and it tries to keep flow of that particular conversation as it is going. So it's more precise in terms of text generation and comprehension, leading to better education outcomes. Then that's enhanced reasoning, which means it is capable of logical deductions, making it suitable for complex problem solvings like STEM. Now, why is this important? This is important because previously, if you look at the earlier versions of LLAMA, you could basically just ask them very simple questions, general questions, and they're able to understand it. Right now, I can ask LLAMA 3.1 to describe for me the process of digestion, including using diagrams and things like that. And it will be able to do that very, very comfortably. I can actually give it a diagram of the human anatomy and ask it to identify various parts of the anatomy. And of course, it is a text-based, LLAMA is a text-based AI component. It is supposed to process text, but it can be combined with other tools, which now make it capable of doing things like image generation and things like that. So enhanced reasoning, it is able, of course, when you combine it with other AI technologies, it is able to deduct logical reasoning, making it suitable for sciences, technology, engineering, and mathematics components as far as education is concerned. Then there's also the element of context awareness. It understands and generates contextually relevant responses, improving interaction in educational settings. As I had mentioned before, if I'm talking about physics, it knows I'm talking about physics. If I'm talking about mathematics, it knows I'm talking about mathematics. If I'm talking about science, engineering, and so forth and so forth, it is capable of knowing exactly what it is that I am processing. Then there's the element of multimodal capabilities. This basically means that it supports integration with things like images, audio, and also video, offering a richer educational experience. Now, what do I mean by multimodal capability? As I have said, I can take an image of the human anatomy and I ask LLAMA 3.1 to identify for me the various parts of the human body. Where are the lungs, where are the kidneys, where is the gallbladder, and probably using that particular anatomy, explain to me the process of what we call digestion. So it will start from the mouth and go all the way to waste removal as far as the body is concerned. So using text, using images, using audio and video, it is able to be combined and it's capable of performing all these things without further assistance. So those are some of the key features that it comes with compared to the previous versions of LLAMA. They were relatively not accurate. The reasoning was a little bit primitive. They were not context aware. They would just be able to churn out text. I mean, the context was not really a very heavy thing on their side. And multimodal capabilities, they were only capable of processing text-based data. But now with 3.1, we're able to perform images, audio, video, including even collecting data from sensors. If I collect sensors and it's giving me this data, though most sensors will give me data in form of text, but then again, you can be able to see that it is capable of doing much better than that. Now, let's look at some of the foundational principles of LLAMA 3.1. Now, it's one of the principles, there are actually just three, but one of the main principles of LLAMA 3.1 is transformer architecture. So it's built on the transformer model for effective language understanding and generation. So what's the transformer model? In transformer model, what we do is we take the input that the user has given us as a prompt, then we break that input into smaller chunks, what we call tokens. Then based on these particular tokens, we are able now to search based on complexity of the question that has been asked. So each token represents something that is different, but all of them collectively are based on some certain context which the AI is actually using to perform its search. So that's basically how the transformer architecture works. Now, in theory, that's what it is, though in practice, it's basically breaking these things and processing them in parallel, which means you run all those tokens in parallel to be able to check what is related to all of them in terms of the context that you're looking at. So that's basically what the transformer architecture is all about. What advantages does this give us? One of them is speed. Because this is parallel processing, it means that I can be able to process 10,000 things at a go. Then the other thing is accuracy. It tries to maintain the context as far as what you're looking at is concerned, because they have things like minimization, where they take this large input or prompt that you've given, then they squash it or they break it down or they simplify it into a summarized version of the prompt. Then that prompt is what is broken into tokens. Then these tokens are processed in parallel. So this gives it quite a bit of speed and accuracy in terms of processing. Now, the other foundation principle of 3.1 is unsupervised learning. As mentioned when I was talking about machine learning, we have what we call supervised learning, where we label things like these are cups, these are tables, these are microwaves, these are taps, and so on and so forth. Then the AI, I give it a photo of a different tap. Now, based on the photos of tap that it has seen, it is able to tell me that this is a tap. That is supervised learning. Then we have unsupervised learning, where we don't give it labels, but we give it data. Then it tries to classify this data in certain ways. For example, these are student marks, these are fee balances, these are lists of suppliers, these are weather patterns from a certain period. So it's able to classify that data on its own based on the context of the data, and that's where LLAMA 3.0 comes in. It's unsupervised learning, which means it's not given most of this prior data, but it has some data that it can be able to use to try and determine patterns as far as the current data is concerned. And that's how it works out. In some scenarios, they call it zero or short learning. It's based on zero or short learning data. So it means you can either give it a small set of data, or you don't even give it the data at all, but based on what it had learned before, it is capable of making inferences over the same. Then there's the element of text generalization, which means it's capable of performing various tasks without needing extensive fine-tuning for each specific task. Again, this brings us back to the context-aware portion of the AI as we're discussing. It is context-aware. So it can be able to generalize tasks. So you don't need to fine-tune it very, very fast. If I'm talking about mathematics, it can easily switch and know that this is now mathematics. If I move from mathematics to physics, it knows that I'm now in physics and so forth and so forth. So it is capable of generalizing these various tasks effectively. So why is LLAMA 3.1 important in education? We look at it from 4 angles. One of them is personalized learning. So it adapts to content to individual students' needs, facilitating differentiated instructions. What this means is that AI is capable of tracking what you have been following. So if I've been researching a lot on motions and fluids, most of the time it will try to focus on that and will try to train me on that particular angle, generate context for me in terms of that specific element that I'm looking at. If somebody else was talking about fluid mechanics, now you can see fluid mechanics and motion are a bit different, even though most of them are mechanically almost similar. ChatGPT is, or rather LLAMA 3.1 is going to be capable of identifying that these two students are researching on probably almost the same thing, but one is focusing on something else. So they could be doing different courses, but this is a common unit in between. So it is able to facilitate differentiated instructions over the same. Then the scalability, which means that it can be implemented in classrooms of all sizes, making it accessible for both urban and rural settings. Now, why is this important? It's important because I can be able to customize these particular models for either small settings, like a small group of people, or I can even go nationwide. I can implement it as far as the entire country is concerned. Maybe all of us are doing physics, so I can be able to customize it to cover the entire country, both urban and rural, or I can simply focus it on a very small group of people, like a particular school or a particular class. That makes it very, very powerful and very effective. Then there's the engagement part, which means they have some interactive tools which can increase student motivation and interest in subjects. Now, if you look at most AI components, they'll be based on things like games, they'll be based on quizzes, they'll be based on mock exams. They could also be based on things like simulation and stuff like that. Now, these interactive tools enables students to be able to try and learn faster depending on their areas of interest. For those who are interested in games, content can be delivered in form of games. So maybe say, for example, identify this particular object. So maybe based on what you have identified, we reward you. Based on what you failed, we penalize you and stuff like that. Then in some scenarios, for those who have quizzes, we can give you these things in form of quizzes, where we ask you a question and simply pop up an answer and the explanation of whether that answer was wrong or right or things like that. So there are quite a bit of tools. Those are not the only exception. Those tools are not the only exceptions that you can be able to use, but they're just examples of the things that you can be able to use to enhance student motivation and interest in these subjects. Then there's the component of assessment and feedback. And here, AI provides real-time insight into student performance, allowing for immediate adjustments to teaching strategies. For example, if it starts with very simple questions, most of the AI models, when it comes to training, they'll start with very simple simple concepts, and they try to see if you understand this simple concept, and they make it more complicated as we go along. A very good example is, let's say we're talking about STEM and we're talking about technology, and I want to teach somebody how to create web pages. It'll start with very simple things like creating paragraphs or creating headings. And if you're able to understand headings, then it goes to lists. If you're able to understand lists, then it goes to things like arrays or block quotes, and things like that. So it goes higher above the ranks as you try to grasp these things more and more. So in the event that you don't understand headings, then it probably now intervenes at that particular point, allowing you to adjust a strategy that you can be able to use to be able to understand this component. Then maybe the examples that it was using were a bit awkward. It can try to be a little bit relevant in the context of the student and stuff like that. So this assessment and feedback mechanism is very, very important to enable us to immediately make adjustments to teaching strategies as appropriate. So that's why LLAMA 3.1 is important, and especially in education. So we are going to look at the role of LLAMA in education, and we're going to look at it from 10 perspectives, which is going to form the larger part of our discussion today. So we'll start with LLAMA 3.1 in ECD, or what we call early childhood education. So in ECD, what can LLAMA be used for? It can be used to tailor content creation. So you want to develop age-appropriate learning materials that cater for varying literacy needs. For example, I can be able to use AI to generate words, and based on these words, they can be able to generate spellings, and based on spellings, they can be able to give relevant examples of maybe if it was teaching somebody alphabets letter A to Z, then I can tell you how A is written, how A is pronounced, what are some of the samples, words that come with A, something like an ant or things like that, and it can be able to reinforce that further and further as it moves along. If I'm talking about people who have gone beyond the stage of learning the letters of the alphabet, then they're learning maybe 3-letter words and so on and so on. It is also capable of doing the same. Then if I'm talking about guys who are now doing pure literature and they want to be able to write poems or generate novels or things like that, it can still be able to be used at that particular point. So when it comes to developing age-appropriate learning materials, it is very, very good, and it caters for that particular need. So again, the educators in this particular space don't necessarily need to struggle so hard with generating this particular content. Then there's what we call interactive storytelling. We can use AI to create engaging narratives that promote reading and comprehension skills. Again, we have what we call text-to-speech. AI can be able to generate some text, and it can actually be able to read that text aloud. So that is what we are calling interactive storytelling. Generate the story and narrate the story at exactly the same time. So with this, I can have a tutor who is capable of generating short stories for the students over and over again, and it is capable of reading it out aloud to them over and over again without getting tired in terms of research and even the narration component. Then you have AI tutors. This one can act as supplemental education resources for young learners, providing support in safe and interactive manner. Again, what you're saying is with the AI, I can be able to run it on my device, independent of a physical person being in place. But because the AI has some inbuilt mechanism in terms of safety and all that, then that makes it a little bit safer and interactive for different type of learners who are now capable of learning at their comfort at different places, so long as they have the devices in place. So that's how LLAMA 3.1 can be used in ECD or early childhood education. Now, how can then we then use it in science, technology, education, engineering, and mathematics? One thing is we can use it for problem-solving assistance because AI will offer guidance on mathematical problems and scientific concepts. So, for example, I can draw. For those people who have the recent version of iPhone, you all know that I can actually take a photo with the phone, and if it's a mathematical problem, it is capable of solving that mathematical problem for me, regardless of the complexity, whether it was calculus or it was fluid dynamics or whatever specific mathematical component it is that you're looking for. It is able to know that this is integration, this is differentiation, this is the equation of a straight line, and so forth and so forth. So that's where now this technology comes in. They are able to help us in solving problems that we can have. So I can take a past paper, try it out. If I don't understand, take a photo of the question, ask the AI, it will be able to generate the content and also explain to me the different parts of that question and why it picked certain areas of the question for answers. Again, we just need to keep in mind that sometimes they might not be very accurate. So again, this is where now the human being comes in terms of how we're going to train them to make sure that they are accurate. Then number 2 is real-time feedback. These AIs will provide instant feedback on students' work, helping them reinforce the learning and understanding. Similar to what I've just mentioned above, in as much as it gives you the solution, it also gives you the feedback instantly. It's not like it has to, you have to like send somebody an email, then wait for them to process, then they'll respond at a later time. No, these things are instant. You interact with it as though you're interacting with a person in real time and is giving you that particular feedback, making sure that you are able to understand these concepts as you move along very, very fast. Then we have adaptable learning paths. Now, this one helps us in adjusting difficult levels based on student performance, fostering mastery of STEM subjects. As I mentioned, similar to what we're using in ECD, we start with the principles. Then from the principles, you can go to applications. Then we can go to other difficult concepts like how we can combine different concepts to come up with newer ideas and stuff like that. So that's where adaptable learning comes in. We have people who are able to grasp the concepts very, very fast. Then we have some people who are not very, very fast with the applications of this particular concept, but they understand the concept. Then you have people who are very, very fast in all of them, and they want to probably come up with other ideas that can be implemented based on those principles and useful examples that have been implemented before. So that's how we can use AI in STEM education. How about in junior schools? Junior schools are, for those people who are in Kenya, this is grade 7 all the way to grade 9. They are referred to as junior secondary schools, so now they are referred to as junior schools. So how can LLAMA 3.1 or AI in general help us in this? One of them is customization of learning materials. So here we can tailor resources to address local curriculum needs and also student demographics. For example, simulations. We can use AI to generate simulations in terms of science labs. We all know that at the moment, most of the schools that we have in the country are not prepared or are not well equipped with science labs. How do these students do things like, for example, electricity or even fluid separation or the various concepts they need to learn? They need to have these various lab equipment or apparatus, and they also need to have guidelines on how they can be able to perform these particular operations. Then they also need to be able to have things like assessments or tests, which they can be able to test on their own and evaluate their understanding of these particular topics or components or curricular needs. So the AI helps us in being able to customize these learning materials. We can be able to create simulations on labs, and the AI can actually be able to assist greatly in that. Then there's also addressing challenges. It helps bridge gaps in access to quality education, especially in underserved areas. As you have mentioned, not every place or not all junior schools in Kenya have labs, and as such, it's very expensive to build a lab and even equip it and supply it with the reagents that it requires. So by virtualizing all these things, we are able to bridge the gap in terms of access to quality education, especially for those areas that are underserved. Like, for example, areas that are affected by security, very rural areas, and even marginalized areas like the northern parts of Kenya, where the government literally pays almost no attention to them and stuff like that. So it's able to assist us in terms of that particular issue. Then there's the component of fostering inclusivity. So AI can assist teachers in providing equitable learning opportunities for all students. One teacher who is very good and they're teaching Mangu, if they are able to generate practicals and questions and explanations, and this is put into the AI and they can be able to recite it back to all the students, then it fosters what we call inclusivity, because it means that all the students have the same exact opportunity for learning from the same person with the same experience and are able to, to compete now on the same level. So that's how AI can be able to be used in junior schools. How about personalized learning? So the fourth application, or where AI can be able to help us, and especially LLAMA 3.1, is in personalized learning. So we can use it in adaptive learning systems, which means we want to use AI algorithms to personalize lessons based on each student's progress. Now, this is very, very powerful, and especially for these people using platforms like Udemy or lynda.com or any of these large digital resources, you realize that they have what we call an adaptive learning system, which means that this thing is able to learn your interest. Maybe I'm doing software design, and it looks like today I'm looking at how to do design, tomorrow I'm looking at database, and so on and so on. It can be able to recommend for me the areas that I need to look at, or the tools that can work better compared to the tools that I've been using. And this is very, very important, because that now becomes personalized as far as I am concerned. We can be 10 different developers, and all of us have completely different interests. So at that particular point, this AI recommender algorithm is able to tell what the area of interest is as far as this adaptive learning systems is concerned. Then we have targeted interventions. Here, it enables us to identify areas where students will struggle, enabling them to focus, enabling focus support and resources. Again, as you've mentioned, if I am doing software design and I am struggling with databases, it can enable focus support on that particular area that I'm not very, very good with, so that now it is giving me help and support to be able to perfect on those particular areas. A very good example of how this has been implemented is, for example, a tool like Test Gorilla. Like in Test Gorilla, they're able to test out, they're able to look at the specific areas that you can be able to gain your strength on, as opposed to the areas that you have learned well. So I'll give you various examples, and based on those various examples, I'll be able to see where your strengths are. If your strengths are in certain areas, then I'll try to focus more on areas where you don't have equal strength. Then lastly is enhanced engagement. This one helps us in customizing learning experiences that aligns with student interests, boosting motivation and retention. Again, not everybody is built for sciences, technology, engineering, and mathematics. Some people are built for arts, others are built for other things like sports and those kinds of things, whether they are performing arts or these other type of arts is called. I'm not sure what the other type of art is called. We have performing arts like sports. Then we have the other presentation arts like drawings or modeling or things like that. So again, it is able to tell where the interests of a particular student are. Then it tries to be able to boost that particular student's motivation towards that particular area in terms of goals. So that's where personalized learning and AI cross their paths. Then there is the other element of natural language processing. Natural language processing, we said, is the capability of the computers to be able to understand natural language. Like, for example, I can't be able to talk to Siri or any virtual assistant and ask it for a question, or even Google or Alexa, ask it for a question, it will be able to take my voice, convert whatever I have said into text, perform search on that text, generate feedback in terms of text, then read that text out aloud. So that's what natural language processing is all about. So why is this important? One thing is learning language learning support. It will enhance vocabulary and comprehension through interactive exercises and conversation practice. So if you wanted to learn a different language, you said one of the things that AI is very powerful with, and especially the large language models, is translation. So it can be able to enable somebody to be able to learn a different language altogether by enhancing their vocabulary, comprehension, and also things like spelling and stuff like that. Then we also have automated assessments. Here, AI will evaluate written work for grammar and style, providing constructive feedback. Now, spell checking, for example, is simple because I'll simply look at what you have typed against a dictionary. But when it comes to grammar, I'll have to understand the context within which you're speaking. So in that regard, you realize that it's not very straightforward by just comparing whether the words are correct or not. It's also comparing where they are placed and the context within which this person is talking. So this is where now the AI will come into play. And we have tools that have been built for this. Like, for example, we have Grammarly right now. It's actually a very powerful tool. It can be able to look into your document, look into the context within which you're discussing, and also be able to allow you to paraphrase these sentences as you move along. Then we have multilingual support. This one will aid in teaching languages by providing real-time translation and conversational practice. So again, compared to the first one, which allows you to be able to enhance vocabulary, this other one will also allow you to have real-time translation and conversation practice. And that's where AI matches education in terms of natural language processing. Then you have computer vision, or CV, as we call it in education. So CV is where we give the computer the perception of sight. Now, using cameras, we can use LiDAR, we can use infrared, basically anything that allows it to be able to have some sort of sight and be able to use that particular sight to be able to perceive and translate the data that has been provided by the computer vision and be able to process it at the back. Similar to natural language processing, which allows us to be able to read the voices of somebody. Natural language processing, computer vision allows us to be able to visualize things like speed signs, for example, things like menus or markings, lane markings on the roadside and things like that. All these are based on computer vision. But how does it help us in education? One of them is interactive learning tools. This enables us to integrate visual recognition technologies for hands-on learning and experiences. For example, if I was teaching people who are deaf, I can use what we call natural language. Then the natural language can convert what we call sign language. I can have a camera that is reading a sign language by a person. Then this particular sign language is translated back into audio that other people can be able to understand. So if I have a teacher who is maybe impaired, they cannot be able to speak, but they understand what they're saying, they can still be able to teach in that particular regard because the computer vision is able to understand the sign language. Then from the sign language, it is able now to transfer it back to the natural language that these people understand. Then there's accessibility. We have aids for visually impaired students with AI-driven audio descriptors and text-to-speech capabilities. Again, I can have things like screen readers, which are capable of reading the contents of a particular screen, and from there, they're able to translate them back in form of either audio or things like that for these people who are impaired. They could be students who are impaired, but then again, there are those people who have what do you call them? Disability, like they don't have limbs and all that. We have AI tools that enable us now to be able to connect these limbs into computer system, and based on their perception, it's able to fill and translate those things back into the students, depending on whether they're going to use speakers or they're going to use headphones or they're going to use augmented reality glasses or whatever it is that's going to be available for that kind of a solution. Then we have environmental education. This promotes awareness of sustainability issues through AI projects that monitor ecological impacts. For example, global warming has been a very big issue over the past couple of years. So we have AI agents that can be able to detect for us exactly how this has happened. How, one, they could be able to read the type of soil that has been available in the place using cameras. then compare to the type of soil that is in a database compared to what was available at this particular place at a certain point in time. So based on that, we can be able to detect things like soil erosion and stuff like that. And then the AI from that particular point forward can be able to advise us on best practices that we can be able to implement to avoid further degradation as far as that environmental issue is concerned. So these are all applications. And these are just a few examples of how you can be able to use maybe something like computer vision in an AI as far as education is concerned. Then seventh is generative AI. So how can we use generative AI in education? One of them is creative expression. This one encourages students to create art stories and music collaboratively with AI tools. For example, right now, if I want to write a poem about my motherland, Africa, or my favorite dog, I can actually use AI to enable me to be able to perform this effectively. I'll simply prompt it to write for me a poem of the same, and it will do that gladly. I can ask it to write a music for on three, maybe say verses, and it does it promptly. I can even ask it to write a story for me of the same, and it does it effectively. So generative AI, when it comes to creative expression, you can be able to see that it becomes a very, very powerful tool because it will be able to do much of the work. But of course, I need to sit down, review the work, and probably correct a few issues here and there. But naturally, most of the work would have been done by the AI models themselves. Then we have exploration of new ideas as a part of generative AI. This one provides a platform for both experimentation, helping students to think outside the box. So for example, I can ask an AI agent to generate for me a new idea on how I can be able to, a new business idea that uses maybe say computer vision for purposes of, improving revenues or sales. And it will be able to tell me, so probably how to use Forex or, things like that. So there will be natural exploration of ideas, which it can be able to help us generate how these ideas can actually be implemented. Again, they are usually ideas, so we need to go back and check whether they are actually practical in terms of implementation. Then there's also support for content creation. So here, it assists in generating lesson plans and also education resources for teachers. So again, as I've mentioned, I can be able to use generative AI, ask it, I want to teach HTML 5.0. Can you give me the course content for HTML5 that I can be able to teach, or maybe what kind of practice question I can be able to give my students, or maybe what are the references, which places can I be able to go and get reference to material that can enable me research further on this particular topic. It is going to be able to generate that very, very effectively for us. So besides generative AI, at number 8, we have data-driven insights. So AI is data-driven, which means it's based on a lot of data, and especially when you're talking about both supervised and unsupervised learning, actually even in terms of reinforced learning, all these things are based on data, because you either give it data that is labeled, you give it data that is not labeled, or you give it data that is partly labeled, partly not labeled, and then you ask it to be able to reinforce its own learning or inferences based on whatever is available. So here we have what we call predictive analysis, which means that we have analyzers that analyzes student data and focus academic outcomes and improvement in curriculum development. What does that mean? I have students and I have a lot of data over the past couple of years. For example, I have KCSE data for the past, maybe say 30 years. Using that data, I can be able to tell which topic has not been understood by students best, which topic is performed best, which topic would be most appropriate depending on the current technological trends that are available in place, and so forth and so forth. So this helps us improve this curriculum effectively. Based on data, we can be able to do some generalization and come up with some sort of analysis based on what that data represents. Then from there, we can ask for suggestions over what areas would require improvement. Then we have performance dashboards, and this one provides educators with tools to visualize and track student progress over time. And again, when it comes to dashboards, they're based on data. I can be able to tell what these students are good at, what they've improved on over the past couple of months or weeks, and what most likely they can be able to be interested in into the future. So that becomes more of a performance dashboard for me that I can be able to use to even further drive a particular student towards their main goal. Then we have targeted improvement plans. So using insights to create strategies for underperforming students or schools. Again, as we have mentioned, if I have a lot of data, like KCSE data, and I'm seeing that students are underperforming, maybe say in mathematics, I might want to understand why that is actually the case, and that would be able to allow me to target the underperforming students or schools if that is the case. Then the ninth component of AI in education is equity and inclusivity. We have spoken about bridging educational gaps, and we say this one targets resources to assist marginalized or disadvantaged student population. And this could be in the sense of maybe they are insecurity, they are affected by insecurity, or in some cases they are affected by maybe say availability of resources. They are in very remote places, so they don't have access to things like labs and stuff like that. So AI will enable us to bridge those gaps in education. Then there's also support for diverse learners. So here it allows us to adapt experiences for students' varying needs, including those with disabilities. As we have looked at computer vision, for example, or even natural language processing, we can still be able to type via a voice. So if I have a student who is who was born without their limbs, they can still be able to do typing work by using natural language processing, which means they can't just be able to dictate to the computer what they want it to do, and it's able to convert that particular text back, that particular speech into text, and vice versa. And the person is able to effectively operate a computer just as similar to what a normal person would be able to do. Then there's also the promotion of equity. This one ensures that all students have access to high quality education materials and support. So again, when we have AI and all data is coming from the same place and has been developed and have been trained by the same people, has the same quality, then it means that everybody else get the exact same quality education regardless of wherever they're going to be. And that's where inclusivity comes in. And that's where AI becomes a very important aspect or tool for enabling us to achieve the same. Then there is lastly the environmental sustainability in education. So we can have eco-friendly projects. So students, it encourages students to engage in sustainability initiative through AI-led programs. Now, an example of this is, for example, assume the kind of practicals that we do within our schools. Some of them involve cutting trees and producing other things that enable us to perform the experiment. When it comes to AI, it can be able to provide alternative projects that you can be able to do that will give us the same results without necessarily interfering with the environment. For example, right now, we need a lot of textbooks all over the place. And to limit this, we can have an AI library which is able to pick for us various topics that we want to learn and puts together a book or a journal that has those specific topics that we're looking at, rather than somebody or a company cutting down so many trees so that now they're able to produce different books so that they're put in the library where I can now go and get the different topics that I need. So these are what we're referring to as eco-friendly projects. Then there is awareness campaigns. Here, we want to utilize AI to promote awareness of environmental issues among students. Again, things like global warming are not very clear and not even understandable to some people. But using AI, I can be able to train you based on data. Say, for example, data that has been collected, whether data that has been collected in Kenya for the last 30 years. I can use an AI agent to be able to put all this data together and draw for me a graph of how the global temperatures have been increasing over time as a result of cutting trees in different areas and so on and so forth. So this one creates what we call awareness campaigns. Then lastly, we have monitoring impact. So this is where we employ AI tools to track and assess the various environmental impact of school activities. So for example, again, depending on the tools that we have in place, they could be just data, or it could be computer vision. It could be analyzing the soil texture as we move along over a period of time. So over time, it can be able to advise us that soil erosion has been rampant at a particular area because of several factors. Of course, it can be able to suggest what these factors are, which somebody might need to look into and actually establish whether these factors are the same. But in all, that is impact monitoring. It is able to tell us that at some point in time, 5 years ago, this was the soil erosion level. At this particular point, 5 years later on, it has gone further. And maybe projecting 5 years, moving into the future, it will become even worse than it has been over time and stuff like that. So that's where environmental sustainability in education comes in when it comes to AI. So those are the 10 areas where AI can be able to be used to improve our education. So let's look at scalability of LLAMA 3.1. We talked about its scalability and how that works out. One of the areas of scale in terms of scalability is flexible deployment, as we've discussed. It is suitable for all ranges of educational environments, from small classroom to very large institutions. So I can use AI for one class, or I can employ it across an entire curricular subject area. It will all depend on how the model is done, how much hardware is available, and in terms of compute resources, how well it can easily be deployed across the various areas that it needs to be employed. So it could be from a very small classroom to a very, very large institution like the Ministry of Education or stuff like that. Then there's remote learning. It supports online education initiative, ensuring the continuity of learning in diverse situations. So we all know that we have different situations. We have natural calamities. For example, we have things like insecurity. In other spaces, we have an availability of resources and so on and so forth. With AI, it enables us to scale up that very fast by improving remote learning. So with the remote learning, we're still able to monitor students' progress. We're able to customize learning activities for the students, and we are also able to use different delivery methods in terms of content for the various student demographics that we have. Then we have adaptive integration. This can be tailored to fit different curricular and education standards worldwide. Again, if Kenya is the way we are learning science, maybe in junior school we have what we call integrated science. When we go to high school, we separate it into biology, physics, and chemistry. And when we go further into university now, even that physics is divided into mechanical, electrical, and all these kind of things. So it can be customized, or it can be tailored to fit these different curricula in terms of education standards, and regardless of wherever the place is worldwide. What's important is we understand what kind of data we're feeding it in and what kind of output we expect from it. Then, of course, the in-between, it is able to figure out how to handle that. Then there's those ethical considerations in AI-powered education, and one of them is transparency. So here we want to ensure that AI decision-making processes are clear and understandable for educators and students. Again, AI is heavily based on data, and data can be inaccurate. So this inaccuracy, we want to make sure that the decision-making process is clear and understandable. It's not bias. Of course, bias is another consideration that we want to look at, but transparency is key. We want to ensure that AI decision-making processes are clear, understandable for educators and for students. Then the other ethical issue is data privacy. We want to make sure that we safeguard information, ensuring compliance with privacy regulations. Like at the moment, or even in Europe, we have the GDPR, or the General Data Protection Regulations, that is in the UK, and in Kenya we have the Kenya Data Protection Act 2019. All these things are all about privacy of data being collected. And we cannot use AI without data. Most of this data, for example, medical records, it's data that is collected from patients and all that. How do we guarantee or safeguard the privacy of these individuals whose this data is collected from? It's something that we need to consider when you're discussing the AI-powered education. Then there's bias mitigation. Active works to identify and correct bias in AI models to promote fairness and equity in education. Now, most of the data like we're using in AI was mostly collected in Europe and America and Australia, though Africa is slowly catching up in terms of data collection. So you can see that if I was to train an agent on this kind of data, it will be biased heavily on where this data was actually collected. We are trying to fix that at the moment. Trying to make sure that these particular models promote fairness and equality in terms of education. Then, what are some of the challenges in implementing LLAMA 3.1 in education? One of them is infrastructure needs. It requires robust internet and technological infrastructure in schools, particularly in rural areas, and specifically if we wanted to implement part of it locally, which means we will need electricity, we will need internet, we will need computers, and so on and so forth to ensure that the particular AI models are implemented effectively. The other challenge is training educators. This one necessitates professional development for teachers to effectively integrate AI into their teaching practice. For example, if I'm talking about sciences, I need to teach science teachers how to do prompt engineering. So prompt engineering is very important, because if I do the wrong prompt, then it's going to give me information based on what it has understood as far as that prompt is concerned, which might not be very, very accurate. So that training of educators is actually a challenge that we need to look into. Then there's resistance to change. Here we want to address potential skepticism regarding AI and technology in traditional education systems. Like, for example, at the moment, I don't think it's a question of whether to use AI or not. I think that has already been passed by time. The question is, how do we use it effectively? Because as you have said, AI has so many applications that we can be able to implement to effectively help us in the education sector. So the question is, what do we use? What regulations do we require to put in place to make sure that certain areas have been taken care of effectively? Things like plagiarism, and copyright and stuff like that. I can easily take somebody's journal, put it in AI, it paraphrases and changes a few parameters here and there and works out everything else, and then I reproduce it as actually new research altogether. So those are some of the challenges that we will get when it comes to implementing AI. So that's the infrastructure need, training of educators, and resistance to change. Most people want to maintain status quo. Now, at this particular point, we need to demonstrate the features of LLAMA 3.1, but because we had exhaustively done this on the previous example, I think I will highlight the YouTube, the previous recording where this was highlighted. I'll put a timestamp on the same. Then for those of us who are interested in seeing how AI can be used to perform the tasks that have been listed here, you can just have that timestamp. I think it's about 10 or so minutes in the presentation. You can just look at it from there. Then we can be able to move forward for the interest of time. And then lastly, let's discuss the future prospects of LLAMA 3.1 in education. Now, one of them is expanding use cases. So we anticipate further integration of AI in various educational formats and subjects. For example, we have a company called Boston Dynamics in the US. They are creating robots, or what you're calling humanoids. And these humanoids are capable of doing things that parents and teachers alike can be able to do, like training children physical activities, training them how to sing, teaching them language, performing nanny activities, and so forth and so forth. So there is quite a bit of integration when it comes to AI and education formats. Like, I'm giving an example. We have humanoids being developed by Boston Dynamics. I can't remember the other Chinese firm that is actually also very good at that. They have been able to create a robot that has the challenge with the robots was the dexterity, the flexibility in terms of movement, left to right, top to bottom, and so forth and so forth. Right now, I think they have come up with motors that actually enables them to be able to move very, very smoothly in that particular aspect. Now, coupled with the intelligence that the machines have at the moment and the motor skills that they have, then you can realize that now we could have robots actually teaching people in classes similar to what human beings are capable of doing. Then the other prospect in education is innovation in curriculum design. There's a potential for AI to reshape how curricula are developed and delivered. As I've mentioned, right now, when it comes to content generation, we might not be very keen on seeing how students generate content, because AI is actually capable of doing that for them. So maybe you might want to come up with different ways of how we are going to evaluate these students depending on how the AI integration takes place. Like, for example, in Kenya previously, it was prohibited. Actually, when I was in high school, it was prohibited to go into an exam room with a calculator. Nowadays, that is surely the order of the day. So I think the shift has been, we're no longer focusing the accuracy in terms of adding and subtraction and multiplication and division, but rather various components like understanding mole concept and things like that. Not how to compute 10 plus 10 more to get 20. That's not a big deal. We want to be able to understand how this particular mole concept in itself works. So that is another prospect as far as education is concerned, how the curriculum can be changed and how it can be developed and delivered to be able to incorporate the AI aspect of things. Then there's what we call collaborative partnerships. We want to encourage collaboration between tech companies and education institutions to drive AI advancement, similar to what LLAMA 3.1 is doing. Facebook or rather Meta, has decided that they're going to give us large language model with so many parameters, so accurate, it will depend on the hardware you want to run it on, but you are capable of taking that and infusing it into your ecosystem and doing whatever you want to do with it. So if you want to be able to teach students or various difficult components like the human anatomy and all that, DNA sequencing, it will all depend on exactly the capability technically in terms of compute power and maybe even the human resource in terms of actually running that. But there is actually that collaboration between the industry and now the education sector, where we're saying the industry is deciding to give us tools that enable us to be able to roll out education more effectively. Of course, we want to remove the boundaries like the geographical boundaries, things like equity. We want to be able to make sure that everybody accesses the same information from exactly the same source, so there is no bias in terms of how this data is collected. So these are some of the future prospects you will have in LLAMA 3.1. So in conclusion, LLAMA 3.1 holds immense potential to revolutionize education by personalizing learning, enhancing engagement, and also promoting equity. And the key takeaways for this particular presentation was emphasis on the importance of adopting AI technologies to foster an inclusive, adaptable, and effective learning environment. And of course, there's the future vision of AI, where we want to advocate for continued exploration of AI in education to unlock new opportunities for students and educators alike. So that is my brief recap on what we had actually learned last time. So I think I'll hand over my program, or rather the program, back to Professor Catherine, who will now be able to invite our discussant so we can be able to discuss any questions and comments that might arise as far as this presentation is concerned.
Thank you very much. There's echo.
Oh, there's echo.
Mm-hmm. You can hear me?
Yeah, we can hear you.
Okay, fine. So I want to say thank you so much, Richard, for that very rich presentation, very engaging, very knowledgeable, very informative. We want to really appreciate your time, your energy that you have put into this as you prepared to come and educate us. Ladies and gentlemen, you've heard from the horse's mouth. At least we are now more educated about LLAMA 3.1, much more than we came into this lecture. And we just want to say I really appreciate our presenter for unpacking this very concept for us. Now we have a basis to even understand the upcoming lectures that will still be talking about AI and how it can revolutionize education. And therefore, in the interest of time, I want to hand over to Leonard so that he can now control the question and answer session. And then we'll wind up. To you, Leonard.
Thank you so much, Professor Catherine. Thank you so much, Richard, for the presentation. I think you have taken 1 hour and a few minutes. Thank you for that. And therefore, this next session, I wouldn't want us to extend to go so deep into the night. I want to believe that we should not go beyond half an hour. So at this point in time, I want to open the floor. If you have any questions and comments, members, you are free to air what you have. Most welcome. I will request you to, in case somebody's hand is up, let them in. Maybe I'm not seeing same to Catholic, because I'm sure Prof, we are also able to usher in somebody. So in case maybe I'm not seeing a hand up, just usher them in. So you're welcome, members.
Anybody with a question? Richard, you could direct them how, like, if they want to raise their hand. That could also be a challenge, maybe.
Okay. Now, if you want to raise your hand on your device, there's a button there that says request to speak. Just click on it. Then we'll be able to see you requesting to speak, and we'll be able to unmute your microphone. So I'm saying Shadrach. So Shadrach, just unmute your mic, then you can ask your question. Shadrach Ogoma.
Okay, thank you. Yes, thank you, moderator. Thank you. I would like to start by commending Richard for the very informative presentation. I am Dr. Goma from Moi University. I have 3 issues which I would like to raise. The first one is on, where we talked of the role of LLAMA 3.1 in problem-solving assistance. And we said something like, you can take a photo of a question or any problem, and then the AI would solve it for you. Now, when we are, when we relate this one to learners, if the AI is going to solve problems for them, how can we talk of, AI assisting them, to learn? That is one. And then number 2, in automated assessment, is it possible to assess essay type questions using LLAMA or this artificial intelligence? And then the last one on it, the generative AI. If AI is going to generate almost everything to students or learners, then does it still remain a tool because it is doing everything? It would be doing everything, for the student. For example, we gave an example of creative expression where a student just simply gives a prompt, and then the creative AI, writes a poem or creates a poem for the student. When does the student learn how to, write poems, for example? Thank you.
Thank you so much, Dr. Shadrach, for that question, those questions and comments. I don't know how we would like to go about it, but first and foremost, before I maybe say 1 or 2 things about the same, let me open the floor. Richard, the presenter, you're also free to chip in as we try to unpack more information about AI. Dr. has asked many things. For example, he's talking of whether we can use AI to assess essay type of questions, indicating that once again, if AI is doing everything, then how are students going to learn?
Yes, thank you. I think, that is very, very important for us to be able to understand. So we have asked, I think the first question was, I said that you can actually use AI like LLAMA 3.1. You can take a photo and it is able to solve problems. There was one small disclaimer on that. it might not be able to solve a problem whose data it has not been provided for. But of course, right now we know if I'm talking about LLAMA 3.1 with 4 or 5 billion parameters, that is actually quite a huge set of data, and most likely it will be accurate in most of the general problems that we encounter. For example, things like weather, mathematics, sciences, things like drawings, generating images and stuff like that. It is able to do that because at the moment, yes, it has that data. But of course, if I was to draw something that it does not understand and ask it to identify the particular element, it will probably be able to tell me that it's not able to do that. And the other thing we might want to keep in mind is that most of these AI models have what we call a cutoff date based on data that they have. So when it comes to things like for current affairs, they might not be very, very familiar with that content. Of course, we know that at the moment, we can be able to connect these agents to the internet and they can be able to collect this data. But then that brings another problem because some of the data that they could be using might actually be fake data or could be data that has not been verified. So those are some of the challenges that even if we're talking about problem solving capability, we have to bear in mind that those ones are still a problem that we have to deal with as we're going into the future with these data. So on the problem solving side, yes, it can be able to solve problems so long as it has the data in place. And we are saying, depending on whichever model you're using, it could actually be having that data, or depending on the size, it might not be having that data, and so that could still be a problem in that particular regard. Now, in terms of essay questions, we have spoken about large language models, and you have said they are able to take data up to 128,000 tokens, which is essentially an entire textbook. So I can give it an entire textbook, and it reads it, and it is able to now go within itself and be able to check what is available in that particular prompt that I've given versus the data that it has in place. So in terms of essay questions, I would say yes, they are capable of trying to understand what people have done. Then they can be able to answer essay questions. So for example, I can ask an AI agent like LLAMA 3.1 if a computer program written in Python is correct. It knows how the Python syntax looks like, and it will probably take your code and try to read it and try to understand exactly what you are trying to achieve. Then looking at the syntax and looking at the various rules of the programming language, it can be able to highlight for me the various problems that I've encountered in that. And I think that is similar to how essay questions work. Now, the other question was, because generative AI is going to do everything for us, then how will the students learn? And that's a very interesting question. And that's why we said one of the challenges we have in AI is the development of the curriculum. We need to come up with the curriculum in such a way that we are saying we don't want to just test students on generating content, but we want to test them on different things. So the curricular development at that particular point should be able to guide us on exactly how to go about this, so that we are now testing other components of education besides only the generating content as far as students' learning is concerned. I don't know if Dr. Shadrach, I've addressed those questions, but the floor is open for other members who can also be able to put in their views on the same.
Okay, thank you very much, Richard. Just to add on that last part, where we are worried if AI is able to do everything, then learners may not be able to learn anything. Just like the way Richard is trying to explain, we as educators have to change our way of engaging, the way we engage the students. For example, let's say I'm training students how to do programming, to perform maybe programming using a given language, say Python. I ask students to write a Python program that solves a quadratic equation. And they go straight into the AI and they get a perfect code. So I will first and foremost tell them to do that, get the AI tool, whether it's LLAMA or whatever, to see how they can generate very clean code. Then the next assessment will be, now I want you, without using AI, to maybe solve this kind of problem, so that they now use AI to help them understand how to carry out certain activities faster and in a very quality manner. Otherwise, if we do not change the way we teach the students, the way we assess them, then basically some of these tools, particularly AI, will be very destructive. Remember, there was a time, I think Richard mentioned that learners in schools were not allowed to use calculators. Today, they are using calculators. So, in essence, what one can say is that technology is here to stay. We therefore should only but try to strive and see how we can make good use of it. Otherwise, it can be very disastrous. So the floor is still open. Maybe I still invite Dr. Shadrack Goma to tell us whether still this need for more clarification, or he's satisfied with some of the explanations that have been given.
I am satisfied, sir.
Okay, thank you.
Thank you.
Maybe just again to add on what Richard has said about these models, they entirely depend on data that is given. Remember, we normally talk of garbage in, garbage out. If you give the computer wrong data, it will give you wrong result. So at times when we see these models perform things very fast and at times very accurately, we almost attempted to imagine that they are more intelligent than human beings, which is not true. So it all depends on the kind of data that we have exposed to these models. Thank you. Any other questions, comments? Ladies and gentlemen, we have, as I said, we don't want to go beyond 30 minutes. We have about 17 minutes to go.
Leonard.
Yes, Prof. Okay,
Yeah, we could.
see a hand.
Oh, there's a hand. Okay, go on with the hand first.
Have I seen a hand, or what am I seeing?
No. I'm not seeing any hand.
Okay, I thought I saw a hand, but I'm not seeing it.
Maybe somebody withdrew the hand.
Okay, I was saying as we proceed towards the end, we could also share that you project that schedule of the lectures, so that we just mention, let members present know the next lecture.
Richard, are you able to share?
Yes, I'm able to do that. Just a minute. Let me just share that.
But maybe you'll hold on a bit. You'll hold on a bit towards the end. I'll let you know when to share.
Yes.
Okay.
I suspect it could be somebody maybe
with a
question. Yes.
Question or a comment. And it seems like the Telegram is giving many people a challenge. That's what I suspect. So we may have to, Richard or Leonard, you could do some write-up just to explain to people in simple terms, step-by-step procedure from the download stage to how to join, how to register for the channel, and once they have already joined, what to click on now to be in the meeting. Because you see, there is that thing that flicks on the screen about joining the I don't know, the channel or what, the video, something. You see what we were saying, people are in some chat. It's actually people. I'm sure people who are trying to join the meeting, and then that flicked on the screen. They clicked on it. They ended up in that chat room.
Okay.
Yeah. So just that step, one page or even half a page, step-by-step procedure, so that now we have many people downloading and getting to the right stages of joining, so that in the next lecture on Monday, we do not have people being left out again.
That's true. I'm seeing a friend of mine here, Samson Nyabura. Are you able to, do you have any questions? Unfortunately, I don't know most of the colleagues here. But at least I've seen Samson. Okay, maybe if there's no comment or no question, Richard, can I request you to share the schedule?
Okay.
Yeah, you could expand. Sorry. Okay, so ladies and gentlemen. Oh, echo. Some people can mute.
Okay, let me mute.
Okay. Thank you. Yeah, so I was saying that to the members present tonight that this is our schedule of lectures. We want to appreciate that Richard has started us very well, and we are done now with the first lecture. This was actually a makeup lecture when the Tuesday one failed.
Prof, just before you continue, I think I can see a hand up.
Okay,
Yeah.
fine. Let's get the questions first.
Samson Nyabura, is your hand up? I'm seeing like there's a hand up. Richard, you can unmute him.
Thank you. Daktari, I'm grateful that at least we have been able to repeat this. I said, my name is Samson Abura, and I'm a student, and Daktari is my lecturer. I believe that as we go along, we can be able also to learn a lot from this. And I'm grateful that Richard has been able to take us this far. Thank you very much.
You're welcome.
Yeah, thank you so much, Samson. Again,
Any other with that comment?
Okay, Prof, you can go ahead.
Okay, so I can proceed. Yeah, so as I was saying that we have a series of lectures, and I was just thanking Richard that he has started us off very well. We know technology is not our thing. We are all learning, and it comes with its challenges. You saw how the first lecture on Tuesday failed. Not really failing, but many people are not able to join because Zoom just capped the number to 100. So we thought we look for an alternative, which was Telegram. Again, I'm sure the low number today is as a result of challenges that people are facing. Some people don't read messages because we've been actually giving instructions that people should download and then join and register. So some may have been locked out because they didn't read and they thought it's just like Zoom, you click on the link and you join. But it needed you to have downloaded the app first. So those of you who have friends who didn't attend and you can reach out to them, please spread the gospel for us. Let people download. I will also do a step-by-step procedure and put on the wall so that come Monday we have everybody enjoying these lectures. As you realize, this is something and this is the direction the world is moving. And if people are there who are volunteering to share with us knowledge, I would really want as many of us as possible to partake of it, so that we kind of like are moving with the trends, the current trends, and we can't run away from them. And we have three main facilitators. The first one being Richard Onyango, who has done it now, the first lecture. On Monday, the 7th, we have Dr. Andriy Koptelov from Sam Houston State University in the USA. And from the schedule, you can see he's going to talk about Introduction to Artificial Intelligence in Education. He'll be talking about AI and ChatGPT. So again, many of us, I'm sure we are already immersed in ChatGPT, and we may be misusing it or using it correctly. But now Andrew will be talking to us about the evolution of AI, its role in transforming educational practices, as he goes specific into some of them, like ChatGPT. So I'll expect that we all attend the Monday lesson, the Monday lecture, which will also be at 8 p.m. And let us invite as many friends as we can, so that we can all benefit, and together we can change our society, together we can change our education system. I don't know if, Leonard, you have any parting words, or I just finish?
Prof, just finish.
The presenter, Richard, you have anything you want to say before I now do the final words?
That is okay.
Richard, you have something to say?
Yeah. No. I think it's okay. You can just finalize.
Okay. Okay. Thank you. Yeah. So I want to say that we appreciate those of you who attended today. I want to say that we also appreciate our presenters. I want to also say that I appreciate Alphonse, the CEO of Diversity Education Institute in the USA, who also is really on top of things with this project. If you've seen some of the web, when you click on some links, it takes you to the website of Diversity Education Institute. He's a key player in this lecture series, and we really appreciate his presence and his contribution. If along the way any of you feels that you are ready to do a presentation, kindly let us know. We'll always lock you in and give you a day to present. We want to make it as interactive as possible, as inclusive as possible. So far, we only have gentlemen. It will be nice to see a lady, a presenter, talking about AI, talking about LLAMA 3.1 or LLAMA 3.2. So we've not locked it out to only these three presenters. No, we have so many. I'll also want to pass my appreciation to our international participants. I've seen Mutaru Tinya. Daktari, thank you so much. I think he must be coming from University of Rwanda. I've seen Nizeimana Gerard. Thank you so much for turning up. I think I had seen also somebody else. There is Nkwama. So we're quite a number of people outside Kenya who have joined this training, and we really want to appreciate. The students who are here, just know this is very important for you. You're going to learn how you can responsibly use AI in your education, because there's one thing to have the technology with us, but again, another thing to use it responsibly. So it is good that you are here, and we really appreciate your presence. So to all of us, it is a thank you. And I want to ask that we bring the meeting, the lecture on the night session to a close by just saying a big thank you to all of us, and see you all on Monday at 8 p.m. Should anybody have a concern in between today and Monday, please feel free to write it on the wall. That wall is there for us to interact, share our concerns, and so forth. Thank you so much, and good night, everyone. Good afternoon, Alphonse. Good morning to whoever is in a place where it is still morning, but to a majority of us, good night. You are free to leave and enjoy your rest of the day.
Thank you, Prof. And thank you for the rest of
You're welcome.
Members, enjoy your evening. The video will be available. I'll share it on YouTube. So for those people who will be willing to have a recap on it, I'll share the link so you can be able to review it at your convenience. Thank you.
You're welcome.
Thank you, Richard.